The objective of our measurement system is to determine whether a coin is real, determine its value, and then sort it. Since all Canadian coins are at least 90% steel or nickel, they can be differentiated from plastic and other non-magnetic metal discs by determining if they are magnetic. Magnetism can be tested using a ferrous vane interrupter.
In order to determine the coin's value, the diameter will be measured. This will be done using webcam and image processing in LabVIEW. By having the coin roll across a surface that is fixed relative to a webcam, coin diameters can be compared by examining the highest point of motion as the coin rolls past the webcam.
The coin will roll through a track with an illuminated panel on one side and the webcam on the other, guaranteeing a high contrast image. Once the coin's size and magnetic properties are determined, it can be identified and sorted.
The sorting will be done using a Quanser SRV02 rotary servo base unit. The rotary unit will have a set of trays in a circular pattern fixed to its load shaft. Once the coin has been identified, it will roll down a track and fall off. The rotary unit will be positioned under the track and will rotate so that the correct dish is in place for the coin to fall into.
The position of the dishes will be sensed using the potentiometer on the SRV02. The location of each disc will be determined and saved so that the correct dish can be moved into position precisely.
A ferrous vane interrupter works on the principle of magnetic field strength. The sensor consists of a Hall effect sensor and a rare earth magnet mounted in a housing with a gap between them. The magnet produces optimum magnetic flux at the location of the Hall sensor. When a ferrous object passes through the gap between the Hall sensor and the magnet, the field is disrupted and the sensor's transistor output switches off.
At its core, a webcam consists of a lens, an image sensor, and supporting components. The camera we'll use has a charge-coupled device or CCD sensor. The webcam's lens focuses light rays on the CCD and electrons are liberated due to the photoelectric effect.
The CCD is made up of an array of individual pixels, each of which has an accumulated charge from the liberated electrons. These charges are transported across the CCD to one corner of the pixel array. At this point, an analog to digital converter turns each pixel's charge into a digital value. These digital values can then be read and processed by a computer.
The system will consist of the following building blocks: one ferrous vane interrupter for determining if the coin is magnetic, one webcam for determining the size of the coin, one SRV02 unit to move the coin dishes, LEDs to backlight the coin for the webcam, one Quanser Q8 DAC to acquire data from the sensors, a Voltpack X2 amplifier to power the SRV02 unit's motor and potentiometer, and a computer to run LabVIEW software for processing the data.
The system could potentially be used in vending machines and other autonomous money collection systems to confirm that real money is being used and to determine the value of the money. With more advanced algorithms, the webcam could be used not only to detect the size of the coins, but also to identify the security features on coins to confirm their legitimacy.